Bismillahirrahmanirrahim. Assalamu alaikum. This is Javed Iqbal, Assistant Professor, Govt Superior Science College, Karachi. Today's topic is electronic configuration. What is electronic configuration? Electronic configuration means arrangement of electrons in orbits, orbitals around the nucleus. In electronic configuration, we require certain rules and principles, and background knowledge of quantum numbers also required. But if we don't know these things at the moment, don't worry, we will inshallah directly deal with the electronic configuration. So around the nucleus there are certain orbits and shells, and these orbits and shells are numbered as 1, 2, 3, 4. You can observe that the closer orbit or circular orbit is known as orbit number 1 or K shell. उसके बाद वाला next is shell number 2 or L shell, then shell number 3, and then shell number 4, and we can continue it. So first shell we can see that is smaller than the second shell. इसी तरह से second shell is smaller than the third shell, and so on. We can also observe that or conclude that the first orbit, as it is smaller than the second orbit, so it should contain less number of electrons. Similarly, second shell is smaller than the third orbit, so it should contain less number of electrons as compared to the third orbit. So how can we find out number of electrons in different number of shells? It has a formula, that is number of electrons is equal to 2n square. Here n means number of shell. For example, we are having shell number 1. So we will put this 1 in this formula, and now we will get a value, that is 2. So number of electrons in first shell is 2. In second shell, we can observe that 8 electrons will be present. In third shell, 18 electrons. In fourth shell, 32 electrons. And fifth shell, 50 electrons. You can calculate any number of electrons in any shell. Then next thing is, each and every shell contains some subshells or sub-energy levels. Their names are s orbital, p orbital, d orbital, and f orbital. How can we say that which shell contain how many orbitals or subshells? It's very simple. For example, if we are having shell number 1, it will have only one subshell. If we are having shell number 2, it will have two subshells. If we are having shell number 3, it will have three subshells. If we are having 4, then it will have four subshells. Now again look at this chart. Shell number 1 is having only one subshell, that is s orbital. Second shell is having two subshells, s and p orbital. Third shell is having three subshells, s orbital, p orbital, and d orbital. Fourth shell is having four subshells, s orbital, p orbital, and d orbital. Similarly, one can ask that shell number 5 should have 5 subshells. Yes, shell number 5 should have 5 subshells, but up to our requirement, f orbitals are enough. So we don't need any further orbital up till now. Next is first shell. How can we say that this s orbital belongs to first shell or second shell or third shell and so on? It's very simple. We can place shell number before subshell, like s orbital of first shell will have 1 in its front. So now it is 1s. Second shell में जो s orbital and p orbitals are there, they will have 2 in front of them. So this is 2s and 2p. Third shell will have 3s, 3p, and 3d. Fourth shell will have 4 shell and 4s, 4p, 4d, and 4f. Next is, how many electrons can be placed in any subshell? It's again a simple, like first shell is having only two electrons and we are having only one orbital, that is 1s orbital. So those two electrons will go to the 1s orbital. So we can conclude that s orbital will always have two electrons. You can see that 2s, 3s and 4s, all these have two electrons. Next is second shell is having 8 electrons. So two electrons are placed in s orbital, remaining 6 electrons will be placed in p orbital. So p orbital will have 6 electrons. So you can see that 2p, 3p and 4p, all these p's have 6 electrons. Next is third orbit contains 18 electrons. Out of 18 electrons, 2 and 6 means 8 electrons are placed in 3 and s and 3p. So remaining 10 electrons should be placed in d orbital. So d orbital will have 10 electrons. Similarly, we can find out uh, 14 electrons can be placed in 4f orbital. Now, how these orbitals can be filled? There is an orbital arrow diagram. We have to follow this orbital arrow diagram. The orbital which is cut by this arrow first will be filled first. For example, 1s जो है इसको सबसे पहले arrow ने cross किया, so 1s will be filled first, then there is 2s, then 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, and so on. You can find out this chain like this. Students should write this chart on their copies, and then they should uh, call these orbitals loudly so that they can understand these orbitals. Again, I am calling this 1s orbital is filled first, then 2s orbital, then 2p, then 3s, then 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d and 7p. So you have to call these orbitals so that you can cramp or memorize these orbitals. Otherwise, there is also a series of orbitals. You can also memorize the series 1s, 2s, 2p. This series is obtained from that orbital arrow orbital diagram: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. Next is there are some examples, like for example hydrogen. Hydrogen's atomic number is 1. It means hydrogen contains one electron. So as we have seen that first orbital which should be filled is 1s. So this electron will go to the 1s orbital. S orbital has a capacity of 2 electrons, but we are having only 1 electron. Therefore, this 1 electron will go to the 1s orbital. So hydrogen's electronic configuration is 1s1. Next element is helium. Helium is having atomic number 2. So helium, the first orbital is again 1s orbital. These two electrons will move to the 1s orbital. So now the helium's electronic configuration will be 1s2. Some people call this 1s square. This is wrong. This is not square. This is number of electrons, that is 2. So this should be called 1s2. Next is lithium. Lithium's atomic number is 3. So again, first orbital which should be filled is 1s orbital. S orbital has the capacity of 2 electrons, so 2 electrons should be placed in 1s. Now still we are having 1 electron, so we have to see what is the next orbital after 1s, that is 2s orbital. So 2s orbital will have that third electron. Now the electronic configuration of lithium is 1s2, 2s1. Next is beryllium. Beryllium's atom contains 4 electrons, so 1s2 and 2s2. Next is boron. Boron is having atomic number 5. It means boron is having 5 electrons. So 1s2, 2s2. After 2s we are having 2p orbital. So 1 electron will go to the 2p orbital. Next is carbon. Carbon atomic number is 6. 1s2, 2s2, 2p2. Now we are having some random examples like neon atomic number is 10, 1s2, 2s2, 2p6. P orbital cannot have more than 6 electrons. So if we are having 11 electrons like in the example of sodium, then we have to write another orbital, that is after 2p we are having 3s orbital. So next electron, 11th electron will move to the 3s. So sodium's electronic configuration is 1s2, 2s2, 2p6 and 3s1. Next is aluminium. Aluminium's atomic number is 13. Again we can see that uh, after 3s we are having 3p orbitals. So 1s2, 2s2, 2p6, 3s2 and 3p1. Next is potassium. Potassium's atomic number is 19. And after 3p, according to orbital arrow diagram, after 3p we are having 4s orbital. So 19th electron will move to the 4s orbital. Now the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. Next is scandium. After 4s orbital, orbital arrow diagram tells us that 3d orbital will be filled. Now the scandium's electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Next is zinc. Zinc's atomic number is 30 and its last electron is placed in 3d orbital. So its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Students may write in their copies 1, 2, 3, 4 all the atomic numbers up to the 30 or 40 or 50. It would be beneficial if they do the electronic configuration 1 to 50. So you will have a lot of exercise for this. एग्जाम्स में हम देखते हैं कि कोई भी एटॉमिक नंबर आ सकता है, तो स्टूडेंट शुड बी प्रिपेयर्ड फॉर एनी एटॉमिक नंबर. Thank you very much.